Hey, today Fabien is back. Last time he did a session about SQL scripting. That was like this video was a massive success. It's still trending like 2 months after, which is awesome. And he's back to talk about a very interesting feature and well known by data warehousing folks. It's called recursive CTEs. Hi, Fabien.
Hi, Youssef. Thanks for having me back again today. We will be talking about recursive CTE. They have just made it to Databricks. When I joined Databricks 1 year ago, I found the lack of recursive CTE to be quite a gap in our product, and I'm very happy that our team managed to fill that gap very quickly. Recursive CTE are very important in SQL because it's the features that make SQL a Turing-complete language, which means you could probably solve any complex algorithm with SQL. Of course, it's not adapted for everything, but it opens up some of your perspective. To illustrate this, I will show you 3 examples on recursive CTE. One very classic, how to drill down a hierarchy. Another one, a bit more fun, how to evaluate a formula of a string. Later one, a sessionization about giving IDs to like a navigation on a website with a different rule set. And one of those can only be solved with recursive CTE. So let me share my screen. I will show you those examples. So the first one is a very classical hierarchy. So it's the data from a table that lives on Oracle since forever. So it's very basic stuff. So I can create the table and insert some values. So basically, I'm putting an employee name and the name of his manager. And we see king being the king has no manager. We are going to run the recursive query about it just to display all the chain of management for every employee. So when you are doing a recursive query, you need to start with an anchor. Usually it's one row, but it doesn't have to be. So it's very depending of what you want to do here. So here the start of our recursion will be king, who has no manager, and I'm creating a pass. So it's I'm using this as an array. In other system, you could have done string concatenation here. Just building the anchor here. What I'm doing within the unionial is I am reusing the recursive CTE inside its own definition, and I'm performing a join just to get the new information from the manager to its next manager. And we are doing some stuff. We are appending all the manager names in place. So when I am running this query, we have the 2 rows that you have in the 2 columns, that you have in the table with the employee and the manager, but we have also all the line of management here. So if we take Alan, for example, so Alan is managed by Blake, but now from here, we can also see that Blake is managed by King. If we go all the way down, we can get to Adams. So Adams is managed by Scott, and we can see that Scott is managed by Jones, who is managed by King. So we have all the chain of management within this path. So this one is very useful when you are doing accounting. You have like nested accounts. You are doing hierarchical data. So employee manager is a great example. You can also imagine when you have different equipment that are tied together. So super valuable. This example is basic, but it's ready to show you the idea. I have another example, which is a bit more fun. So it's very basic. Here, I'm putting a formula in a variable, and the formula is passed as a string. And basically, again, very simple. I'm doing one number, one operation, one number. Everything is an integer. I don't need to cast something. But what I want to do here, I want to try to evaluate all this. So in the anchor part of my CTE, what I'm doing, I'm just taking my rule formula because I need to keep track of where I am. But I'm just taking the first number. So it will be my initialization point. Then I will be adding new rows to this output depending on the character I will be checking. So you see, I've put a variable which is called level that helps me to keep track of where I am in my formula, and basically I will handle them 2 by 2. So that's why you have a level times 2 here. The first one will be to determine what would be the operator, and the second one, what would be the operand. So it allows me basically to convert something very stringy to like proper expression, and increasing, of course, my level. So I will be running this query. So okay, so I have like all my characters. We can make a quick check. 6 times 3 is 18. 18 divided by 2 is 9. 9 times 9 is 91, minus 4, 77, plus 7, 84. So that's the correct answer to my formula. The last example is a bit more complex. I'm creating like imagine you have having some weblogs. You only have very basic information about actions and a timestamp. Here I will show you the content of my table. It's very generic. So basically I have 20 rows, and I have an ID from 1 to 20. Basically the ID, you see, it's also the minutes of my timestamp. And just for the first 6 rows, I am at the 11th hour. For the next 10 rows, I am at noon. And for the last 4 rows, I am at 1 p.m. So first rule, we will define a session that ends after 5 minutes of inactivity. This one, we don't need actually recursive CTE to solve it. Imagine, so you're browsing a page, and yeah, your session will log you out after a certain time of inactivity. Here we are using only window function. So basically I am ordering my dataset by timestamp, and I'm checking if the differences between my current row versus the precedent is over 5 minutes or not. And I have just also a case with the null just to handle the first row. If all this is true, then I am evaluating this expression as a Boolean, either true or false, and converting the Boolean to tiny int give me 0 or 1. And then I just need to aggregate this series of 0 or 1 to have my session ID. This will become my output, and we can see it's okay. So the session ID are already matching the hours. So all the ID here, because I have always less than 5 minutes between 2 actions. So this is session 1. Here I have a 1 hour break. This is session 2, and you get the idea. This is session 3. Okay, perfect. Now let's change a bit the rule of the game. Now what we want to do, we want to evaluate the session based on the start of the session. So imagine you are like you are putting items in a cart. Usually you have a set time to validate or continue that cart. So here we can't really solve this with a window function. Because the first session is very easy, because you have it's the first time of your series, so it's very easy to get it. But the second session, you're not sure, because you can add +5, but you don't know exactly when that will fall off. So it's very hard to determine when the second session is starting. So to cover this, we are using a recursive CTE here. So what I'm putting in my onshore, I'm just starting with the first rows. I can clear this here. So I'm just starting with the first rows, and I will check against the table for the next row. So it's ready ID equal ID +1. And basically the logic is here. I will keep track of the starting of my timestamp, and I will update it only if my current timestamp is superior to my session starting timestamp +5 minutes. If that's not the case, I'm not touching that column. And if it's the case, I will update that column. And it's the same for the session ID. If I did update, I will add 1. Otherwise, I'm adding 0. And when I'm running this query, we'll see the result set now will be very different. So we can see here the same 5 minutes are grouped together in session 1, and this is the starting of the session. But here, when I I'm at the 6 minutes, so the difference is becoming above 5 minutes. So I am creating a new point here, and I'm doing a new session. Here the session is, I have more than 1 hour, so I have another session. But even here, if everything is concurrent by 1 minute, a bit the same for ID1, we still put here a stop, and we are reaching 5 minutes. So now we are updating the new session's beginning starting time, and we are adding a new session ID. And to solve this, you really need recursive CTE. And that's it for my example. So one very basic, one a bit more fun, and the latest one a bit more complex, but I think it has some values for my peers.
And the good news that those notebooks will be available in the GitHub repo, and which means everyone can just go and try it and see how it works.
Absolutely.
Thank you so much, Fabien, and see you soon.
Thank you, Seth. Talk to you soon. Bye.